So we are recording now. So good afternoon, everyone. It is 3 p.m. Eastern Daylight Time on August 20th, and this is the HamSCI Telecon Zoom. And so today we will start off very similar to the way the Tangerine Group does it, where we will get everyone's introductions and updates. And then after that, we're supposed to have, yeah, there he is, Nick Hall Patches on. He's going to give us a nice little introduction to his Eclipse observations that he has collected from various people and himself, and has very nicely posted to Zenodo. And then I think, and Jay wants to talk more about Misra after that. And we'll see if anyone else has anything else they want to discuss. So let's see. So I'm Nathaniel, W2NAF. I've been busy working on starting to teach classes this week, which I was just talking with Jay about, and so far it's going smoothly. Just working on doing class prep and keeping up with all of the Zooms that we have going on all the time. So why don't we go over to Mike, AA8K.
Greetings to everyone on the conference. Back to you, Nathaniel.
Thank you very much, Mike. Always nice to see you. Carl, K9LA, how are you doing?
Oh, I'm doing real good, Nathaniel. And hello to Nick. It's been a couple of years. And I have nothing to report, so just looking, just to listen. That's it.
Great. Thank you very much, Carl. Scotty, WA2 DFI.
Hey, Nathaniel, and good afternoon to the group. Just working on the Tangerine SDR data engine, and kind of got distracted a little bit by the magnetometer. We're trying to put the finishing touches on so we can get some boards out to people. And Tom, I'll have a schematic for you to review in a few minutes. So, and that's about all that's happening here. Go ahead, Nathaniel.
Thank you very much, Scotty. I think that's, yeah, I'm very glad we're getting that magnetometer moved along. And I was thinking this, the low cost station that Case Western has been working on, I think that's being a really nice like prototype. You know, we're able to get some hardware out there sooner rather than later with that system. So I think this is going very well. Okay, great. So Tom, N5EG.
Oh, good afternoon to everybody. Not too much this week. Just reviewing some information on clocks and performance requirements for the HF receiver. Back to the group.
Great. Thank you very much, Tom. Bill, AB4EJ.
As I mentioned Monday night, I've been focusing on getting set to be able to support multiple channels used in the local host software, and that includes, I'm going to, just for version 1, say channel 0 is the ring buffer stuff, and it has multiple sub-channels. Channel 1 is FT8, and channel 2 is Whisper. And so it's going to default to those things to begin with. You'll be able to turn the modes on or off as you like. So I found out, I think I can support ring buffer, snap shotter, and fire hose simultaneously at the same time. It looks like we have enough processing if you use something like an Odroid or higher. So testing so far has suggested that that is possible. My other major project of the week, which I did yesterday, was to get a couple stents put in my heart. So I'm not going to stay in here very long. I just want to give you a little quick update and then go rest and follow doctor's orders. But anyway, I did want to just give a little brief update. So that's back to you.
Yeah, thanks a lot, Bill. I'm sorry to hear about the stents, but I'm also really glad that, you know, it's going smoothly so far. So please rest up and be well. All right, so let's see. Gary, AF8A.
Afternoon, everyone. Just here reading the mail, keeping up on things, and I'll pass good wishes along to Bill as well. Take care.
Great, thank you very much. Christina, KD8OXT.
Hey folks, I'm working on getting the data wrapped up from the WWV Centennial Festival of Frequency Measurement. We're putting a paper together, so I sent out an email to everyone who collected a data set to please fill out a survey and make sure that we've got your coordinates correct so that we don't have any errors in our figures. I know that we missed a few data sets the first go around. I think Mike caught that his plot hadn't shown up. And there were a couple just from sending out emails to the interest list. So if you collected any data, if you had any friends who collected data, make sure that they get in touch with me if the data is missing and to confirm that everything's good. And then Nathaniel, if you have some time after we wrap up here, I don't want to throw it at the whole group, but I'd like to spend a few minutes talking with you about these structs in FARLAP. So that's pretty much what I'm up to today. Back to Net.
All right, thanks, Christina. I'll try to make some time for that. If we have to do some breakout groups later, breakout rooms. All right, and Nick Hall-Patch, go ahead.
Hi, I'm Nick, VE7DXR, and as Nathaniel mentioned, I had uploaded an article on monitoring various medium wave stations, or one medium wave station actually, from various monitors throughout the United States and Canada during the solar eclipse in 1997 and the effects on the signal strength that occurred there. I might be here under false pretenses a little bit because Nathaniel introduced me as going to talk about that particular like write-up that I did. But I was hoping today actually more just to say something about just the process of like monitoring AM broadcasters, or the carriers of AM broadcasters, as a way of checking on propagation conditions. We'll get to that presumably. I'll stand by for the moment. Thank you.
Great, thank you. And thank you very much, Nick. Unfortunately, we don't have David McGaw on at the moment, but his group at Dartmouth, they have an ongoing project monitoring AM broadcast stations for evidence of traveling atmospheric disturbances. And they have a number of papers out on that. So you might be, I can pass that information along to you in those papers, and you might be interested in that.
Yeah, actually, that would be great if you could, please.
Great. Okay. Why don't we go to Tony Rogers?
Hi, this is Tony Rogers, 80EN out of the University of New Hampshire, and really just in and out. I'm here to lurk today. Thank you.
Great, thank you very much. Bob, Whiskey Kilo 2 Yankee.
Hey, Nathaniel. I am currently sitting by Stone Mountain Lake. Not sure what the signal will be like. I hope. Oops.
That sounds great, Bob. We're glad to hear it. So good to hear you from Stone Mountain Lake. You sound just fine. And let's see, Dave Witten, KD0EAG.
Oh, hello. Not much to report. I'm just coming here a bit late on after trying to keep up. I didn't get to attend this last week, I don't think. Thank you. Over.
Great. Thank you very much. Okay. Did I get everybody? All right. So why don't we open it up to Nick Hall-Patch, and then we can have some general discussion.
Okay. Yeah, the articles on the effects on propagation of medium wave signals from the solar eclipse was actually 20 years after I first started doing this sort of thing. So I'm sort of a bit of a one-trick pony, as Carl, K9LA, already knows, because we've worked together on like on some of the data sets and so forth over the years. But back around 2000, I was working with Bob Brown, NM7M, And I'd figured out a way that you could actually use the carrier strength of AM broadcasters on the upper part of the medium wave band as an analog for 160 meters. And in those, or 160 meter propagation, I should say, in those days before SDRs, essentially it would involve a computer-controlled receiver that could tune very rapidly between various signals and record the software that would tune them could record the signal strength from them. And what we were looking at was enhancements that occurred in signal strength from stations in Australia and Asia that occurred, as I say, at sunrise, because DXers have always known that these enhancements occurred, but it is really sort of difficult to define what the heck was going on. It was mostly anecdotal information at that time. And so what we were trying to do was essentially, set up like a chart recorder of the signal strengths that, as they changed as local sunrise approached. And these were all documented in an article in QEX back in 2001. And if anybody wants to have a copy of it, I could probably give them one. There was also one that we did. I was talking about medium wave broadcasters, but in fact, there are short wave broadcasters as well. Fewer now than there used to be. But Bob Kavanagh, B3 OSZ or Z, depending on where you are on the side of the border. And I had done some monitoring of a station in Meyerton, South Africa. And what we saw from that was that in this case, it was sunrise at the transmitter enhancements, which again, radio amateurs are aware of in their DXing exploits. And it was quite amazing how the signal strength, like the actual pattern involved in the signal strength changes were so similar, because Bob was in Ontario and I was monitoring from Victoria, British Columbia. And in fact, I'll just see if I can bring up the example chart from that, which means that I have to, okay, I've got it there. And let's see if I can share the screen for a moment. And can I find it? Here it is. So I don't know, is that coming across? Mm-hmm. Yeah, okay. So, as you can see, the enhancements and signals that occurred, this was back in 2001, were extraordinarily similar, and this was nothing to do with what was happening at the receiver. This was all what was happening in the transmitter. How we explained that was a whole other thing, but essentially that gives, I think, some background as to what where this came from, this solar eclipse monitoring. And in fact, I've been doing this since then using usually medium wave broadcasters, just simply because the carrier is available and it is constant, but the propagation isn't constant. So it's really an easy way to at least see what's happening to the signal strength. The difficult part, for me at any rate, is trying to explain, why this is taking place. Bob Brown at the time was, I had sort of hoped to just hand the data over to him, because essentially I'm a technician. I guess he'd been dealing with grad students for quite a while, and essentially he said, well, I think you can work this out. So I had to sort of learn a little bit about propagation, but I still really don't understand a lot of what's going on. And I think, well, that's probably something that K9LA has probably said over the years as well, is that it's still sort of mysterious when it comes to 160 meter frequencies at any rate. I guess that's the essence of the background. you know, since software-defined radios have come in, it's become much easier to actually zero in on specific, you know, frequency, carrier frequencies. You know, sometimes to the point where you can separate like 3 or 4 of them on a given channel, say 1557 kilohertz or something like that. But you know, those might be separated by like 1 or 2 hertz. And you can actually get to the point now where you could zero in on each of those individual signals and monitor them, whereas the original monitoring was essentially, I think it was, we were using mechanical filters in the receiver, so you know, looking at about a 400 hertz passband, so that, you know, like, sometimes there was some question as to what on earth one was listening to. Yeah, you know, so I think that that's really the bulk of the background. I'd be very interested to hear more about the traveling ionospheric disturbance monitoring to find out just how they're doing it, because you know, as I said, the understanding of what's going on is the harder part, but it's actually, for me at any rate, has been just really difficult keeping up with the idea that or the ideal of making the, you know, like the monitoring process automated, so that you had time to actually sit down and consider what the heck was going on with what you were observing. So I'll throw the things back to you. You know, if anybody has talked to, you know, like has looked at the solar eclipse write-ups and so forth, I'm happy to answer questions about that. But essentially, you know, everything is there, including how the data was actually processed from the various commercial software-defined radios that various people were using in order to get, you know, extract those signals from it, because it's something that it doesn't seem to be that widely known. It's not a, you know, once you do it, it's not that difficult process, but you know, like I still essentially am talking to people who say, well, the S meter is reading such and such, you know, like at such and such a time, and you can go so much further along than that. So anyway, I'll throw it back to you, Nathaniel, and see if there's any questions or any observations. So thank you very much.
Thank you very much, Nick. Does anyone have any questions for him? This is the data set that he has posted most recently.
Yeah, that was, sorry, I think there's about 6 of them now, from 6 or 8 of them. I didn't count them before we
yeah, you have a
started.
number of them up there.
Yeah, and they're, yeah, the write-up was actually about the station, broadcast station, 1160 kilohertz KSL, which is what would you say, a clear channel station. So, but it was monitored from a site in Oregon, one in British Columbia, one in Alberta, and one in Minnesota. And the thing is that most of this was sort of done by people who were just doing it, whether they were doing broadband SDR recordings. And this was essentially found data. You know, they were just doing it because they were DXing. You know, during the eclipse, that is quite interesting to be able to extract, you know, like the information from each of these different recordings, and see what the differences were. Since then, we've added several other, you know, just again incidental recordings that people made during the eclipse, and it's sort of up to the students, so to speak, to see if they can find common stations that are being received by each location, and be able to extract the you know, the signal strength data from that. It's not something that I've done because it's quite time consuming. Anyway, again, back to you.
Yeah.
Yeah, this is David, N1HAC. I'm presuming that none of these were taken with any kind of precision reference. We're actually doing Doppler shifts on AM broadcast stations currently down to, you know, sub-10th hertz level.
Yeah.
But I presume this data probably would not be accurate to that level.
So just so you know, Nick, this David McGaw here, he's the one I was
Mhm.
telling you with the group that's doing
Yes.
that. Yeah.
Mhm. Yeah, and I gathered that, yeah, that you were actually looking at frequency shifts rather than signal strengths. And yeah, the issue here is that no, it would strictly be, what's the word I want? It would be, you know, comparing with the, you know, like the moment before, so to speak, because although it's possible to clock some of the commercial SDRs to GPS, most of the people who are just DXing, you know, like this is not really of much interest to them, the idea of, you know, that extreme accuracy. So yeah, you would be looking only at relative shifts in the frequency, but you wouldn't be able to say that what the absolute shift was from these recordings.
Yeah, the other thing that we've noticed about all this is that the carrier gets quite complex bouncing off the ionosphere. It does not come through as a single frequency much of the time. And
That's
a good question how that would affect your signal strength measurement.
okay. I guess the thing there is that you know, that too has been observed just in sort of day-to-day DXing of these you know, sort of long distance propagation. That if you bring up a, you know, like a very fine scale display of the you know, of say a specific channel, yeah, sometimes you will see like a fixed, you know, like, frequency that good to, you know, even 1/10 of a hertz or something like that. But more often you will see smearing, you know, especially on signals that normally aren't heard. You know, as you say, there's a lot of, you know, sort of strange things going on in the ionosphere. And so that includes, you know, like frequency shifts or time delays, you know, phase shifts really. And you're looking at, you know, in some cases, like a trace that's spread out over 2 hertz or more. You know, recently we've been monitoring signals in this part of the world from a transmitter, you know, like a medium wave transmitter in Benin in Africa, and during the summer months, and it regularly, depending on, you know, like where the auroral zone is, it can spread out over 2 hertz, and in fact it enhances the signal strength. Again, one of these things that have absolutely no idea what's really going on there. But it also means that if there's ever any audio, it tends to sort of pop up and down because, you know, like the carrier strength is really all over the map, you know, like from what would normally be quite a steady signal if you were somewhat closer to it. Well, back to you.
Yeah, indeed. Yeah, unfortunately, in our data, we are not keeping track of amplitude. I wish we were, but the PI on this, all he cares about is the Doppler shifts at this point. So that's what we have record of.
Okay. Yeah, well, I don't know. This data might be useful to you because the Doppler shifts would be, you know, like the relative Doppler shifts would be observable. It's just that you, and in fact, you know, really, in the signal that I was monitoring, KSL 1160 kilohertz, is actually a bit of a frequency standard. It's pretty much right on 1160.0000 kilohertz, and so you know, essentially you could, I guess, use that as your frequency standard because you know, each of the monitors would, you know, be there would have to be I guess a fixed frequency that they would see most of. You know, yeah. You know, the more I think about it, the more difficult it becomes. But the fact is that you know, like the actual signal itself is very solid and very, very accurate.
Yeah, that's good. Most of the stations that we're watching in the Northeast do not have well-controlled carriers. Some of them drift. Some of them just have a periodic frequency So we found that we have to have something in the near field that we can pick up, and then we back out the inherent shifts from the actual propagation Doppler shifts.
Mhm.
Yeah, what we're seeing is big changes at the dusk and dawn, of course.
Mhm.
Then at night, depending upon activity of the ionosphere, it can either be steady or it can be quite complex.
Yeah, yeah. No, that definitely dovetails with what like what medium wave DXers are sort of been digging into things a bit more, have seen over the years, and actually like the medium wave DXer is listening for program detail, and the distortion that comes from like what you're observing on the carrier is definitely noticeable. It makes us makes a signal and sometimes unreadable. But given that you're listening outside the service area of the station, it's not surprising that they could care less. It's just it becomes something that's more of scientific interest. There's some software called Carrier Sleuth by a small company called Black Cat Systems. And they can take the output from, or that the software can take the output from a like a commercial SDR recording, and they can give you a sort of a visual output of a specific channels down to fractions of a tenth of a hertz if you want to. And so you can see the most incredible detail of what is happening to carriers, on that. And it's I've been talking to the developer actually about whether or not there's a lot of detail that he's obviously deriving there, but then he's just displaying it as a waterfall. So he might be somebody you want to talk to actually if there's this sort of thing here. Yeah, exactly. Yeah. So
Right.
you're aware of this. Yeah.
We're developing our own software. We may be able to combine resources.
Yeah.
I think, yeah, I mean, this is also the sort of thing that we've been doing with especially with the low cost personal space weather station. The Case Western Group has done a lot of work on this sort of thing. Steve Serwin, WA5RF, has done a lot of work on this sort of thing, also using Spectrum Lab. And that's also where we're going with the Tangerine SDR as well, is to be able to routinely make these sorts of observations. But with things like the with both the Tangerine and the Lowcost system, to look toward making sure we have GPS DO level accuracy and calibration of the amplitude data as best as we can as well.
Yeah. No, it's again, it's fascinating. I mean, you can't see it with this display that you brought up. I guess it's Nathaniel who brought this up. But when you mouse over one of your own recordings, you'll get a display. If you sort of zero in on one of those carriers, you get a display of the time and the signal strength and the exact frequency. I think it's only to a tenth of a hertz. Yeah. But there's a ton of information in there, but unfortunately, it's just shown as a waterfall. So it's there. It's not something that's delivered at the moment. That's except as a waterfall.
Yeah, and that's something we've kind of been struggling with too. Dave McGaw mentioned this, that these carriers they break off, so you don't just see one, but you see 2 or 3 or more. And I think, and Steve Serwin was the one who really first enlightened me to this fact. But now we're trying to kind of wrestle with how do we deal with this on, say, the low cost personal space weather station, where we want to, we have kind of conflicting requirements. We want to be able to get the lowest bandwidth characterization of the quote unquote Doppler shift measurements as possible, but at the same time be able to capture all of this information. And so I've been pushing Case Western to basically save, I think we decided on like a full 8 kilohertz of data around the WWV channel. But I know that C. David Kasdan really wants to try to find some clever way of just picking off the individual channels and really reducing the amount of data. And I'm not sure of an appropriate way to really do that. But those are some of the things we're thinking about.
Yeah, the thing with WWV is you know the modulation frequencies very well.
Mm-hmm.
And in fact, 8 kilohertz may not be required, since I think the highest modulation frequency is the 1 kilohertz tick. Of course, you need some bandwidth for the rise and fall time of it. But.
Yeah. Right.
So,
yeah.
Sorry, can I interject again?
Yeah.
David, so what frequencies are you monitoring for, for these shifts that you're observing?
Well, we have a set of AM broadcast stations in the Northeast that we're monitoring. We actually get everything, or can get everything, that's received within this area, but they're a finite set that we're actually actively collecting the data for and watching. But we have stations, we're based at Dartmouth, but we have one at down at New Bedford, Mass, Jenny Jump, New Jersey, Schenectady, New York, Messina, New York, and I think I'm forgetting one. We have 6 stations out there.
Yeah. And so
we have one at Cornell.
Yeah.
And so we're using basically our RTL SDR down with a down converter and GPS locked so that we get the frequency accuracy. But a Raspberry Pi is doing a double level FFT that first channelizes the AM carriers and then narrows them down to a couple of hertz around each one.
Okay, yeah. So I guess the reason I was asking is because if I bring up a domestic channel, it looks very much like the carrier sleuth display. At night, you will be looking at upwards of 10 to 20 different carriers all gathered around within, somewhere in the order of the 2 or 3 hertz of the central frequency. And I just think, so how are you separating those out so that you know that you're actually getting exactly the shift on the channel that you're monitoring?
Well, we're trying to focus on clear channel stations. They're not as clear as they once were, but
okay,
focus on ones that are clear in the north.
Yeah. Okay, yeah, you're right about them not as clear as they used to be. I'm thinking of one here that 1530 kilohertz, which is just extraordinary how much is it's not, you're not receiving audio from all those channels, but like the number of carriers, it's well, better part of a dozen channels, and being, unless you can choose one that's say 5 or 6 hertz out of the mainstream or something like that, I'd have real difficulty in being able to sort of zero in on something like that. So you're looking at, okay.
Yeah, that's the.
Yeah, okay.
Nathaniel's brought up our first round of it.
All right.
And that's the sort of stuff we get at night. And what we're trying to do is look for gravity waves in it. It's an interesting task, given that the waveforms, the frequency waveforms, are so complex. But we've now expanded the system. This was just we had I think 3 receivers at that time. We've got 6 spaced around now, getting a lot more data.
Okay, yeah. So you're monitoring probably WVZ 1030, I guess, and WGY.
Well, WVZ is one. Our primary one is WGY. And,
correct, yeah.
That's kind of the center of our coverage area. We have a receiver there that picks up the near field, so we have a good
Mhm.
area reference. WBZ, we actually don't have a receiver close enough to get the direct ground wave clearly, though occasionally, or much of the time, we can see it here up at Dartmouth.
Mhm.
So we do use that. We're trying to use some of the other ones. There are some stations down in the New York area that we're trying to make use of, but Jenny Jump does not see the ground wave for some reason. It's just
Okay.
far enough away that we're not getting ground wave.
Okay. Yeah. Yeah. No, it sounds like a fascinating problem for sure. I'll have to look more closely at some of.
That
So
paper is online.
okay.
We're working on
Yeah,
active research right now. We have a student
Mhm.
working on it, but we don't have an updated paper yet.
I put
Yeah.
the link to the paper in the chat.
Thanks.
And Gary asks, does multipath propagation occur on medium wave frequencies? If so, I'd imagine that the further this station from the receive, the more of a chance for variation.
I don't think multipath in the sense that, say, it occurs at VHF and UHF frequencies. I think more there are different paths that it takes that ionospheric reflections take. There's also the difference between you were saying earlier about ground wave, and there's a cancellation area effectively, outside the service area of these medium wave stations where high angle skywave is actually being reflected back down and can interfere with the ground wave.
Mhm.
So that is in effect it's certainly a longer path because it's going up to the ionosphere and coming back down, and this could occur even in the daytime. If you've got a high enough angle, you're actually blasting right through the D layer, coming back off the E layer and coming back down again.
Yeah, we've certainly seen it with Christina in the Farlap plots that Christina Collins have recently produced. The ray
Mhm.
traces. You can see E region and F region very clearly hitting the same place. You get multipath just from E region hops and F region hops at HF, and I imagine you could get similar sorts of things happening down at medium wave as well.
Right. Yeah. I guess though, in this sense of it, the reflections are taking place at ionospheric heights,
right?
But it's not traveling, bouncing off a building or something.
No,
like
no,
that.
no. But
Yeah.
it's still multipath. Yeah, just off.
Yeah. It's not in the common, the common sense when people talk about multipath, they're talking about bouncing off, structures and so forth. And yeah, the longer wavelengths mean we're talking about greater distances.
Yeah, but just on medium wave, you still get the O and X paths, and that's two paths right there.
Yeah.
Correct. Yeah.
And you actually get multiples of those.
Mm-hmm. Yeah. And that's I guess that's the correct way to look at it, is that even with any sort of bounced path, which would of course usually occur after dark at medium wave frequencies, you will get obviously the like the one simple one, say off the E region, but or even the F layer, depending on how, but the high angle could be you need to get two hops or something like that. So yeah, and again, you should be able to see those differences. You can certainly hear them if the station is audible, because of the like the phase cancellation and so forth that take place because of the time differences essentially of the arrival. I'm not sure you'd see it so much in the amplitude, but again, you would see it in like the phase shifts and like the time delays that you would see.
Nathaniel's kind of stepping through our plots, and one of the things that we're trying to do is correlate it to total electron content from the GPS measurements.
Okay.
As well as what we can get from DigiScience, but primarily we're trying to correlate it to TEC because those show gravity waves.
Mm-hmm.
But this initial paper's result was showing that the waves in total electron content and what we're seeing are essentially orthogonal to one another. So now we're trying to get more instances. We've got some good
Because you
events
see
the last few months.
You see the wavefronts here and here. Those
Mhm.
are the and there. So you're
Yeah.
saying that the wavefronts for the AM TIDs are going in the other
Yeah,
direction.
yeah, that's what we're kind of seeing, but we didn't have a whole lot of data points, of course, for this paper. So
Right.
we're trying to get a whole bunch more information now. I'm trying to automate it using some tracking software.
So Bill, actually NQ6Z, I think one thing that you've talked about, you've described yourself a number of times as being frequency agnostic, meaning that, you know, you're very interested in the ionosphere, not just from the perspective of HF or MF or VLF, but you're very interested in the whole big picture. And I think for me, one of the problems is it's just there's so much to do on one section there's so much to do in one frequency band. It's hard to diversify yourself and kind of see the big picture. But you know, we are starting to see, you know, David McGaw and Nick, you've been doing the looking at the medium wave, Jim LaBelle, and then, you know, I've been doing a lot of HF work. I know a lot of people who do HF work, and Bill, you've been doing some VLF, and so is Morris Cohen and the other people you've been working with. How do you see bringing all of this together?
Whoa.
I suppose that's a good question, given what we're trying to do with the personal space weather station. The matter of how do you program it? What data are you hoping to get out of it? And I'm wondering on that score whether we can have those online in such a way that we can dynamically change what data they're taking, depending upon who's doing the study.
That's certainly a goal for the personal space weather station, is to make it so that we can send something out and send a command out and change what mode the station is listening in.
Like getting time on a telescope.
Yeah, it's that sort of idea.
Yeah, the problem, of course, with this is it'd be nice to take all the data all the time, but the terabytes involved are just outrageous.
Yeah. But yeah, how do we put all of this together to see the big picture?
Yeah, it sounds as if you have, you know, like a larger version of the problem that, you know, we already have, you know, medium wave monitoring of overseas signals. It's just there's so much data already, and this is without a really serious program of data gathering. There's you got to do something with this at some point. I'm glad that, you know, like you are, and you know, like in these cases that you're illustrating, but there, you know, like there's I'm sure there's a ton of things we could find out. It's just that we have to be able to zero in on, you know, like what it is that we're trying to observe from all this data.
Mm-hmm.
Now, one of the holy grails is I don't know quite what you would call it, but some kind of intelligence that is looking for particular phenomena, certain events, and can, you know, autonomously decide to save certain pieces of data. We've been having that problem out in the field for ages because our primary interest is in auroral roars and such, which are up in the 3 megahertz, and well, they're harmonics of 1.5 megahertz. And if we're taking the data continuously, we're like sampling at 10 megasamples per second. And you can't just feed that to a disk and then go back some arbitrary amount of time later and decide and then go look in it. We try to get daily plots back and decide what data needs to be retained. But
yeah, that sounds like a universal problem for sure, because I know I've dealt with some scientists who have dealt, I supported oceanography for some time, and that was the same problem that they had there too, is that, how do you pick out what it is you're going to save? And of course, then then there's the regret that you didn't save something else when somebody else comes along and says, well, if only you'd saved that, then I could have found out this, that, and the other thing. Yeah, it's a major issue. What I'm sorry, David, you mentioned auroral something, and this is something I haven't heard about.
Auroral roar.
Okay, that's what I thought you said. What is it?
It's harmonics of the electron gyrotron frequency.
Gyro frequency. Oh, okay.
Gyro frequency is generally around, up in the auroral regions, it's around 1.5 megahertz.
Mm-hmm.
And it can, you can't see that directly on the ground, but it can couple to harmonic modes at 2, 3, 4, we've even seen, I think, 5 times harmonics. So 3 megahertz, 4.5 megahertz, and up. And they show up as transient oscillations that we then pick up down on the ground. There's also MF burst, which is another phenomenon that's in the same frequency band that we also look for.
Oh, okay. Yeah, no, I'm sorry. This is complete news to me. That's really interesting.
Yeah, in fact, there's, I was late because we were having a design review on a pair of CubeSats that we're putting up to study these phenomena. So it's going to have, they have 3-dimensional loop and dipole antennas deployed from a CubeSat. And both satellites themselves can pick up these phenomena, and we're also hoping to get some interferometry out of 2 satellites. And we're looking at the roars. We're also looking at what's called AKR, which the auroral kilometric radiation is actually in the AM broadcast band. So we don't get to look at it very much down, in this hemisphere. It's too much interference. So we have systems down in at South Pole and places like that to look at that.
Yeah.
Really intriguing. Thank you.
Jim LaBelle, who Dave McGaw works for, he gave, we got to everybody. He gave a presentation at the HamSCI workshop on sources of auroral radio emissions that we as hams might be able to look at, and of course he included the main scientific ones as well. So I just put the YouTube link to his talk in the chat there.
It's interesting. The aurora is not just visible. We actually study radio and X-ray aurora.
And okay, so radio aurora is actually, what people who are monitoring propagation be more concerned about. And you're talking about radio as an emission,
right?
Correct. But where is it emitting from? As a zone compared with, say, the auroral visible zone, which is what most people, when they think of the aurora, that's what they're concerned with, is visible aurora. But
well, it's all over the place. Some of this is from the visible zone, and in fact, the roars we think are.
Mm-hmm.
So the other things are more difficult to nail down, and like AKR, we think is much, much higher, and that's part of why we're trying to study it. That we don't know exactly where it's coming from.
Wow.
So if we could get some multiple receiver sites well synchronized, we might be able to DF it.
Right. Huh. Yeah, that sounds very intriguing. Just the whole concept of being able to do something like that. You know, so many things are possible. It's just that getting the resources to do it.
Mm-hmm. So this is actually something we see from Jupiter up in the 20 megahertz range, but that it was thought that we wouldn't see it here on Earth, goes out, not in. But we found that no, that it actually does sneak through.
Well, that sounds really good. I think we're getting close to 4 o'clock, which is nominally when this meeting is supposed to end. But it can stay going on for as long as people want to hang around.
Yeah.
But we might shift. I would like to. Christina wanted to ask me some questions about the ray tracing, so I think I might want to work with her a little bit on that. And then I think Jay, if you would like to show some of your MISRA things, we can do that as well. Maybe we can do some breakout rooms. And also I can tell you, Jay, that Bill Engelke, who is overall in charge of the software, he sent a message saying that he is planning on buying and reading a copy of the MISRA standard. So he has that duly noted. So,
okay. Yeah, I saw the chat.
Okay, great. So maybe what I can do is anyone who wants to go into the Christina, should we do a breakout room for that, and other people can come watch if they want?
Yeah, that sounds good. I think I may have cracked it while we were talking, but we'll go over it together.
Okay, that sounds good. And then anyone who wants to stay here and keep chatting, they can do that. Now, I'm still kind of getting used to this breakout room. Now, what would be really nice is normally Zoom lets you, what do you call it? Zoom lets me as the host assign people to a breakout room. But what I'd really like to do is basically let people choose what breakout room they could go to. But I don't know if that's possible. So is there anyone who wants, what's that?
I have no idea how to do that.
Okay. So who would like to go hear about Farlap stuff?
Sounds interesting, Nathaniel, but I got to run. So.
All right. So it may just be Christina and me. All right.
I'm gonna have to.
Okay. This is Bill. I'd also like to do it, but I have to run as well.
Okay. Sounds great. So So with that, Christina and I will head off to a breakout room. I'm going to stop the recording right here, though. That was a great session. I'm really glad that Nick and David got to talk. And yeah, and so anyone who wants to stay here and chat, they are welcome to do so while Christina and I are in the breakout room. And anyone who wants to go, you are free to go. So thank you very much.
Okay.
Bye,
Thank you.
everybody.
See you Monday on the Tangerine meeting.
That sounds great. I will see you then.
Take care. Stay safe, everyone.